Hi, I got something really exciting that I think lots of you have been hoping for, which is an example of doing on-device learning, specifically around anomaly detection. Um, so I got this repository here. It's a demo application I put together on the Cortex-M4 dev board and the STI-IT Discovery Kit. Let's take a look at how it works in action. So there's a demo.bin file in here that you can flash, or you can flash from scratch. And at first, we're just going to collect data, and this is normal state. So I have the device idly running on my desk, and let's add some up and down. All right. And after we've collected some data for these two classes, now we know what normal behavior is, and I press the blue button. We now train a clustering algorithm, actually the same one as we do in the studio, and now we have an anomaly detection model working. Let's try it. Idly is naturally okay. Do up and down. Nice. And let's do wave, something completely different. Definitely anomaly, shaking, definitely an anomaly. And the moment that we lay it back on our desk, we return to normal quickly. All right, so how does that work? Well, it's pretty straightforward. As what you can see in this repo is that we have basically the anomaly detection training code that we use in the studio ported to the embedded device. And it's pretty fast, like a second, as you saw on a Cortex-M4. It still relies on a lot of the stuff that we do in the studio. So it still relies on a trained model. It requires a signal processing pipeline as set up in a Gimpulse, and also the anomaly detection block to actually be configured. However, we don't use any of the trained clusters. That's actually something that I think would be useful to add, but we don't have it at the moment. We don't use any of the trained clusters, but rather what we do is we just feed the new data in all the time, and then finally run that k-means clustering thing. The cool part is that it's still some engineering. You still need to determine what the signal processing pipeline is, but after that, it looks transparent to the user. They just feed in what is normal, and we'll tell them whenever something starts deviating from the mean. The code for this is really trivial. I've put the example here. But in essence, we are just feeding data from a buffer here into the anomaly detection code. Then we train, it's single line of code, and then finally we run a classify function with new data, and then we get the anomaly score out of there. This is very much a tech demo, not a finished product, but I was talking to TE this morning, and this is something that they actually wanted. We've been talking about this. Sales and the FAEs have been talking about it at least for quite a while, so I figured it would actually be good to put something here together. So if someone is looking at a problem like this, we actually have something for them to show them. So we'd love to kind of spark a conversation internally to see what we should do with the stack. All right, thank you.